Our next topic discusses adding and subtracting radicals. In order to do that efficiently, we have to go ahead and remind ourselves of some terminology. Okay? When you're dealing with radical expressions, the number that tells you the type of root is called the index. The number underneath the radical symbol is called the radicand. And if you happen to have another number out in front being multiplied, that's called a coefficient. Okay, so these words pop up a bit in this topic, so make sure you understand what they mean. In fact, here they are in our first definition. Okay, two radicals are called like radicals if they have exactly the same index and exactly the same radicand. Only the coefficients can be different. Okay, so for example, 5 cube roots of 2 and 20 cube roots of 2 are like radicals because they have exactly the same index and exactly the same radicand. Okay, but they have different coefficients. That's okay. Any two radicals that don't have the same index or don't have the same radicand will not be like radicals. One thing I'd like to point out about like radicals is that they're an extension of the idea of like terms. Okay, so for example, 10x cubed and 45x cubed are like terms because they have exactly the same variable x and they have exactly the same exponent, 3. Similarly, something like 10 cube roots of 6 and 45 cube roots of 6 would be like radicals because they have exactly the same radicand. That's like having exactly the same variable. And then they have exactly the same index. That's like having the same exponent. Okay. As we move on with operations on radicals, you're going to notice that the way we treat polynomials and the way we treat radical expressions is very similar. You have to be careful judging whether two radicals are like radicals, because sometimes, even though they don't look like radicals, they actually are. Right? So for example, if we're looking at the cube root of 3 and the cube root of 24, at first you might think, well, this has a 3 underneath the cube root and this has a 24 underneath the cube root, so they're not like radicals. But if you simplify the cube root of 24 like we did over here, you see that the cube root of 24 is actually 2 cube roots of 3. So now you have a cube root of 3 and a cube root of 3. So you do have like radicals. Right? The moral of the story is, before you can tell whether two radicals are like radicals, you have to simplify both of the radicals. Right? So then we have enough information under our belts to go ahead and talk about the main idea. Right? Remember, this topic is about adding and subtracting radical expressions. Well, the bottom line is only like radicals can be added or subtracted. Okay, otherwise there's nothing you can do. Right? If I give you the cube root of 2 plus the 4th root of 2, those guys are not going to be added because they're not like radicals. Right? So only like radicals can be added or subtracted. And then to actually add or subtract like radicals, collect the coefficients. Okay, collect like terms basically. If you have 5 4th roots of 13 plus 7 4th roots of 13, altogether you have 12 4th roots of 13. 5 apples plus 7 apples is 12 apples. Right, so it's very similar to collecting like terms. Let's work some examples. Alright, so example 1 says simplify, assume all variables represent positive values. And then part A gives us 7 root 54 minus 3 root 24 minus root 6. If we want to have a chance of collecting any of these radicals together, they have to be like radicals. So we're going to need to take each one of these radicals individually and simplify it. Now the root 6 doesn't need to be simplified, okay, because it can't. There's no pairs of factors in 6 that we can pull out anyway. So let me go ahead and do the simplifications for root 54 and root 24 very quickly, and then we'll move on with the actual collecting of like radicals. So there's my simplifications for the two unsimplified radicals. Root 54, after you do the factor tree, ends up being 3 root 6, and root 24, after you factor it down, ends up being 2 root 6. So now back in the original problem, I'm going to have to replace root 54 with 3 root 6, and I'm going to have to replace root 24 with 2 root 6. So let's see what that gives me. Okay, so instead of writing 7 times root 54, I'm going to write 7 times 3 root 6 minus 3 times, instead of this root 24, I'm going to put 2 root 6. And then this minus root 6 tags along. And now you'll see the only type of radical I have is a root 6. So let me go ahead and simplify my multiplications. This is 21 root 6 minus 6 root 6 minus root 6. And you want to think of this minus as a minus 1 root 6. So altogether I have 21 root 6s minus 6 root 6s, right? So that's going to give me 15 root 6s. But then also I have to subtract this last one, which is going to give me 14. So 21 apples minus 6 apples minus another 1 apple is going to leave me with 14 apples. In this case, my apples are root 6s. So there's your simplified result. For part B, we have the square root of 75x squared plus the square root of 12x squared. Again, right now these are not like radicals, so we're going to have to simplify each one individually so that we hopefully get like radicals, which we can then collect. So let me go through that simplification quickly. So here's our simplification for root 75x squared. The 75 breaks down into 5 times 5 times 3, which means you get a 5 outside the radical and a 3 inside the radical. 5 out, 3 in. Then the x squared, you have 2 factors of x that you want to break into groups of 2 since it's a square root. 2 goes into 2 one time with no remainder, which means you have 1x on the outside, x to the first, and then no x's remaining inside. All right, now let's break down the square root of 12x squared quickly. For the square root of 12x squared, the 12 breaks down into 2 times 2 times 3, which means you will get a 2 outside, and then this lone 3 will remain inside the radical. The x squared, again, you have 2 factors of x that you're breaking into pairs. 2 goes into 2 one time, so you have 1 pair, which gives you 1x outside, x to the first, and then no x is inside since there's no remainder. So now I have to go back to my original problem and replace my simplified version of each radical and then try to collect like radicals. So root 75x squared is going to become 5x root 3 plus root 12x squared is going to become 2x root 3. Right. So at this point we do have like radicals. We can combine this root 3 and this root 3. The way that we'll do it is by adding the coefficients. So we're going to go ahead and take 5x plus 2x, which is 7x. Okay, so 5x apples plus 2x apples means that I have 7x apples. Or 5x root 3 plus 2x root 3 means that I have 7x root 3.